So let's finish the lettering. So we work with the letters. Now we are going to work with numbers. So I'm going to show you how to work with numbers really quick from 1 to 10. Again, we are going to take 4 squares. So starting with, I'll just start over here, just zoom in a little bit. So starting with the number 1, so go straight down, and that's number 1. Then I will leave a box, then go to number 2. You can see how I utilize all 4 boxes. Okay, then number 3, number 4, number 5, nice round circle, number 6, seven, let's do 8, 9, 10 is just a 0. Okay, so that was all about lettering. Let's go to the next topic, which is overview of the drafting tools. Now I'm going to show you what all are the tools that are used in doing technical drawings. So what you see over here is a drafting board. Now this is the board where we paste our drawing sheet for drawing anything. For example, I would put it underneath the slider and put my drawing sheet and paste it somewhere over here. Okay, obviously the drawing sheet is going to be underneath the slider, not over it. And then I will use the rest of the tools for working onto my drawing sheet. The one that you see on the top left, this one is called a compass. Now compass, the first one that you see, is used to transfer dimension, and it has 2 pointed edges, one on this side, one on the other side. But it's not used for drawing, obviously, but used for transferring your dimensions from one drawing to the other. Now the second compass that you see has 1 pointed edge on one side, and the other side it has a lead, it has pencil. Now this one is used for drawing circles. Okay, so you put this one sharp point on the piece of paper, and then you would draw the circle with the help of the pencil. Okay, let's go to the next picture over here. Now this is called a triangle, or even an adjustable triangle. Now what the triangle does, it helps us make lines which are vertical, horizontal, and at different angles. So I would be putting my triangle somewhere like that onto the sheet, lined up with my slider. Okay, so this thing is called the slider, and in some cases it's even called a T scale. The reason why it's called a T, because some scales have something like that, so it slides in this direction and that direction. Okay, so but the one that you see in this picture is called a slider, which moves up and down. So this slider is going to move up that way as well as going down. But the triangular or adjustable triangle that we have moves this way and that way. Okay, so this is how we would be working on our drafting board, where we slide the slider up, where we slide the adjustable triangle to the right, to the left. Now this adjustable triangle, I could adjust, like if you look in this picture, I could adjust the angle that I wanted to draw something on. So I could have this thing go at another angle, maybe something like that. And I could tighten it with the knob, set it to the angle. Like if you look over here, you will see the angles. You see 20, 10, 0, right? These are all the degrees that you would be needing for doing any drafting or any hand drafting. Now let's go to the third picture. This is an eraser template. Now what is this used for is if I have some kind of lines on my drawing which I want to erase, I would put my eraser template, something like that, and line it up with the hole and then erase it using an eraser. Okay, what you see on the next picture is the eraser. Now again, the eraser, two different types. You see one looks like a pen eraser and the other one is the regular original one that you use all the time. But you would use the eraser on this template, and you see the holes which you would line up with your drawing and use it for erasing and keep your drawing nice and clean. Okay, because at the end of the day, it's really extremely important to have your drawing look really clean and nice and presentable, right? You don't want all those dirty smudges and pencil smudges on your sheet, which you get it with the eraser or even the slider. So you have to make sure that you spend time and you're doing a professional job, right? In the fourth picture that you see a brush over here. Now this brush is used to dust off all the eraser sheddings that falls onto your drafting board. So I would continually keep brushing off the eraser left over from my sheet, because then if I don't and I move my slider up and down, it will ruin my drawing sheet, right? So that's what I'll be using the eraser for. The next one is our sharpener. This sharpener is used to sharpen the lead for the pencil. Now I don't have a picture of that pencil over here. You just see these pencils, which are drafting pencils, and the other pencil would look something like this, but it has a pencil edge, right? So that edge goes into this sharpener and you turn it from the top and it sharpens the lead. Okay, let's go to this last picture where it gives the whole overview of what most of the drafting tools are and what you would be using it for. The ones that you see, this one and that one, are called templates. Now these templates are used for making ellipses, making circles, or you see different sizes of ellipses that you have. You have circles over here. Sometimes you have rectangular template. Sometimes you even have furniture templates where you get the same thing, but on the template you will have different types of furniture. Like I would have a table, I will have some chairs, and I probably would have a template for the toilet, for a toilet seat. Then I could have different types of templates, right? Like the kitchen sink. So all these templates, you would get it in something like that, which is easier to use, easier to trace. Now the small little box you see over here is the drafting box. Now the drafting dots are used to paste your drawing onto the sheets on four corners. Now the reason why you do it, because when you're using your slider, your paper would move, and once the paper moves, everything is a big mess. Your lines are not vertical or horizontal or or any other direction, then everything gets messed up. So that's why you would have to use some drafting dots, or sometimes even tape works pretty good. Even right now I'm on the same picture. I wanted to tell you more about the slider. So the slider slides up and down, as I said. At the same time, the slider is used for primarily all horizontal lines. So I could use this edge, or I could even use this edge for making horizontal lines. So I would slide it up and down and make all my horizontal lines only with the slider. Okay, horizontal. Keep that in mind. That's why you're using the slider. One of the reasons is for horizontal lines. Second thing is your triangle will always line up with your slider. Okay, and if I were to make a 90-degree line, it would be really easy because this is 90 degrees. If I were to make a 45-degree line, so right there is 45 degrees. Or, as I said, you could adjust it to whatever angle that you needed. Okay, so let's go back again to the last picture. Some more stuff that's used for our drafting. On here you see the pencils. There's the lead of the pencils. Now this lead can go in that sharpener. Okay, but I don't have the pencil to show you over here, but I hope you understand what I try to say. Now the next one we have over here is the adjustable curve. This adjustable curve is, as the name says, for drawing lines which are curved. Okay, so this curve you could always take it out, open it, turn it around, keep it straight, and I could draw lines that are something like that. Okay, or I could draw a line that looks something like this. So this adjustable curve comes in handy because it even has a ruler onto the curve, so I could measure my curve just right on the ruler. I don't know, you cannot see it really clean, but it's right there. All the measurements are right there. Okay, so anything left in here, there's another small little box that you see on this corner. Now this is for removing the smudges. It's a small little pad, eraser pad. So any smudges that you have on your screen over here, you could even clean with the eraser pad. So that pretty much gives a whole overview of the drafting board, the drafting tools, and how to kind of use it. Okay, I'm not going to have a video presentation where you learn how to do that because I don't have a camera set up onto the drafting board, but I'm pretty sure you get an idea of how to use the drafting board, what tools are used on the drafting board, when to use it, and where to use it. Okay, now let's go to the next topic that we have in here is scales. So we are going to cover scales where I show you why to use scales, where to use scales, what are the different types of scales, how to draw using scales. So let's go and do that. So this page shows you all the different scales that are there that mostly be used, starting with the architectural scale. These two are the architectural scales. The next one is the engineering scales, then the mechanical drafting scale. This one is a metric scale, and again this is the same metric scale, but it's got a different scale that you see here. So now the architects use the architecture scale. Okay, so both of them is the architect scale. Now civil engineers use the civil engineering scale. Now the one on the top is the mechanical scale. So who uses it? Obviously mechanical engineer. Mechanical engineers. Those who make the machine parts and machine drawings and stuff like that. And finally we have the metric scale. Now metric scale is the scale that is used all over the world pretty much, and obviously it's not used much in America, but that's the metric scale. This is the metric scale as well. Metric scale is a lot more easier to use because it is divided in 10 parts, like if you see from 0 to 1, and there are 10 subdivisions, right? So it's really easy to calculate when you're using a metric scale. On the other hand, if you're using an architect scale or an engineering scale, it's divided in 12 parts. Okay, so when anything is divisible by 12, then the math comes in the picture, and you have to work with the calculations. Okay, so this is what we use in America, as I said, and this is what we use in the rest of the world. Rest of the world pretty much uses just this one scale, and we have to use this one, and this one for doing the same exact job. Okay, now let's go venture out more into the architect scale and see how the measurements are made using the architect scale. So I'm just going to draw a rough little sketch over here. Okay, it's just a rough block floor plan of a house. Obviously it's not detailed or anything, it's just a single line, and I will use my architecture scale to measure it. Okay, and then I will put maybe a bathroom over here. Okay, so what we have is the living room, we have the kitchen, then this is the bathroom, and this is the bedroom. Okay, now we are going to measure the distances, which is all the way from here to here. Then measure this distance, and measure this distance using what? Using the architect scale. Now let's see, how do we read the architect scale? Now architect scale has all these numbers that define the scale of the drawing. Now we have to understand why we use scales in the first place. Now the scales are used in the first place is because if I were supposed to draw a house 20 feet by 30 feet, okay, and I were supposed to send it for construction. So if I'm drawing on 1:1 scale, then the problem is, if I need to print it out, or if I need to make a drawing that big of a size, then I need such a big paper to draw it on. And obviously it doesn't make sense making a drawing onto full scale, especially if it's as big as a house. So that's when what I use is these scales to scale my drawing down, but at the same time it's still onto the specific scale. So if I use 1:8, the one that you see over here, so what that corresponds to is one feet on your side. 1 feet on your side corresponds to 1/8 inch on your drawing. Okay, so if I measure on my drawing just 1/8 of an inch, then I already know that in real life, when I do the construction, that is going to correspond to how much? To 1 feet. Okay, now let's check out how big this distance is. Okay, now these distances could be any numbers because I'm just doing it approximately, right? So I'm going to use the architect scale and bring it down to put it onto the right spot. Okay, so I will line it up with the start. I think that should be fine. Okay, so now if I want to measure the distances, you see two set of numbers. One is for 1/8 scale, which is going from the top. It's 0, 1, 2, 3, then you have 4 right here. Then you have 5, 6, 7, 8, 9, 10, 11, 12, and 20, and this is 21. Correct? Now if I see there's another number down which is below, which is 12. Now what is the 12 for? Now 12 for is this scale. If I'm going in and reading in this direction, then that's 1/4 scale, right? And this is what? This is 1/8 scale, which is the top one. So the dimension that I have in my drawing right now is 21 feet, right? So that distance I measured with an architecture scale of 1/8 gives me a dimension of 21 feet. Now if I were to use 1/4 scale for the same exact thing, I'm just going to move it till it lines up. It lines up right there, right? Now let's go check the measurements, how much is going to be on 1/4 scale. So I start with 0, then I'm going towards the left. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Right? It's actually 10 and a half. Okay? So it's 10 feet 6 inches. Now how do I know it's 10 and a half? Because it goes 10 and then it goes straight 11, right? I cannot see what the division is right there. So what I would be doing is I would move my scale and put it on 10. See, now it's lined up with 10, and now go back, read this way. So I have 0 to 10, that's 10 feet, and then it's right in the middle, so that's 10 feet 6. Okay, so if I were to use for the same distance 1/4 scale, then my distance would be 10 feet 6 inches. Okay, so for the same exact drawing I could use two different scales, 1/4 reading from right to left, or 1/8 reading from left to right. Okay, and obviously 1/8 is half of 1/4. That's why if this is 10 feet 6, then this has to be double on that scale, right? So that's how we would use the architecture scale. Now if you want to look, let's take a couple more dimensions using the architecture scale. Or I could even use the other scale, which is over here. Okay, so let's put the architecture scale back and use the 3/8 scale for getting another dimension. Now I would like to take the dimension of this. Okay, so how much is each feet? So if you look from 0 till here on 3/8 scale, that's how much? That is 1 feet. So if I were to measure this distance, it is, I'm going to put it on 0, line it up on 0, there you go, right in the center, and then I read the top one, right? I'm not using this, I'm using this. So this is 0, this is 1, this is 2, this is 3, this is 4. So it's a little less than 4, right? So what I would do to get the measurement, I'm going to slide it on the right side, line it up with 3, which I did right here, and read it in this direction. So I have 1, 2, 3. This is how much? 3 inches, 6 inches, 9 inches, and 12 inches. So it's right about 3 feet 9, 10 inches, right? So I would measure that on the scale of 3/8 is as 3 foot dash 10 inches. Okay, so you understood how the dimension work, right? Over here, if I were to use 3/4 scale, I would move it onto this side, and take my measurements. Okay, looks like I cannot get on the other side of the screen. Okay, there you go. We go even more. Okay, I cannot scale that, but I had to move it, but for some reason my screen is set and it couldn't move in that direction. Okay, so let's read this distance on to that scale. Okay, so if I put it right on 0, going right, okay, and reading in this direction. Okay, so this distance is how much? 1, because you see this whole thing is 1 foot. 1 and 2. This is 2 feet, a little less than 2 feet. How less? Now I'm going to put this on 1, see, and then I read backwards. So that's 1. So that's 1 foot. This is 3 inches. This is 6 inches. And this is 9 inches. So if I'm using the 3/4 scale, this would be 1 foot dash 9 inches. So you understood how the architecture scale works? So the other scales work in a very similar fashion. Now let's try using the other scales. Now the next one is the engineer scale, which is the civil engineer scale. So we would use that and try to measure some distances. Okay, so I'm going to draw on this side and use this particular scale. Let's zoom out a little bit. I'm going to put it on 100, and I would erase some stuff, get it out of the way, and I am going to draw another drawing right here. So let's take our pen and let's draw. So I'm going to make what? Civil engineers draw what? Like a site plan. Now, so I am going to have a site plan. In fact, you know what? I'm just going to have it pretty straight lines. I'm not going to have angular lines because measurement would be a problem for me because I'm using this scale onto the screen. Okay, so we'll measure a couple distances on here. Now, if you wanted to know what this is the top view of how your plot or a site looks like. You might have your house over here with the roof, and you might have some contour lines, right? This shows the slope of your site, if it's sloping up, sloping down, if it's flat. So I'm going to use my engineer scale or the civil engineer scale to measure this site. Now the first thing that I need to understand about civil engineering scale is the scale is always multiples of 10, right? So from 0 to 1, if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a lot like metric. It's not like architect scale because that's a multiple of what? 12. So it's really easy to use the engineering scales. Like from 0 to 1, it could stand for either 10 feet, it could stand for 100 feet, it could stand for 1,000 feet, it could even stand for 1,000 miles. Okay, so this is the scale that is used to measure the maps. You know, you have your maps that you use for your driving. If you're drawing a map for the city, if you're drawing a map for the house, so you would be using this scale to read the map. Okay, so what this scale could stand for is 1 inch. Okay, 1 inch on my drawing could correspond to 100 feet. Okay, which is this 1 inch, right? Now 1 inch could correspond to even 1,000 feet. At the same time, if I were working with really big maps, 1 inch could correspond to 100 miles. Got it? So that's how this scale works. Now if I were to use this scale onto our site plan that we have and try to record the distance, okay, I'm going to put it right there, and the measurement that I am going to take is from here till here. Okay, that's the arrow. Okay, how much is that distance? Okay, again I'm using my scale. I click on it and I line it up. I line it up in the right position. It's starting from 0 and it goes all the way up till here. So let's measure this. If I were to have this site plan on a scale of 1:100 on my engineering drawing, I would measure this as how many feet. Okay, this is 100 feet, this is 200 feet, this is 300, this is 350, and right about 360 feet. So this would be 360 feet in real life. Okay, you get that? So now I'm using that on the 10 scale. Got it? So I could get the lower measurement of this using again the same exact scale, but instead of 10 I could use 60, right? So 60, if I'm using 60, then how do we have this? So either 1 inch could be 60 feet, 1 inch could be 6,000 feet, 1 inch could be 600 miles, right? So let's see how many feet this is over here. So I'm going to count from 0. How much is that? 1 inch is equal to 60 feet, right? So this is 60. 2 inch is going to be 120. 3 inch is going to be how much? So we require a little calculation over here. So the distance would be 13 multiplied by 60 is how much? Let's calculate. 13, which is what you see right here, right? 12, 13 multiplied by 60 is equal to 780 feet. So this distance is going to be 780 feet on the scale of 1 inch is equal to 60 feet, right? So I hope you understood that. Now let's go to the next one, which is going to be the mechanical drafting and the metric. With the mechanical drafting scale, you have pretty much, it is like architecture scale, but there are a couple of scales which are 1/16th, then 1/50th, that are a little different because they are divided in 16 parts. For example, if you see 16 is divided into 16 parts from 0 to 1. This was divided in 12 parts. This was divided in 10 parts. Now this is divided in 16 parts. So if you look real close, start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, right? So if I were to measure a line drawn right here from there to here, let's try it from there to here, and using probably 3 cubes, right? And here to here, here to here, there, whatever this is. Okay, this is like just the mechanical part. Now if I were to measure starting there and get this distance, how much would that be on my 16-inch scale. So I'm just going to take these three lines. So let me just go back a little. So it should be right about here. So let's use our engineering scale. Now I'm going to put it down here, line it up with what? With 0. Got it? You see 0 is right here. How much is that? That is 1. Sorry, that is half. This is 1 inch, right? And we have a little over 1 inch. Now how much over do we have over 1 inch? Now if you look, this is 1/4 of an inch, or sorry, 1/8 of an inch. This is 1/4 of an inch, starting from 1, right? Starting from 1, this is 1/8 of an inch, 1/4, 1/2. Okay, this is 3/4, and this whole thing is 1 inch. So that is how it's divided. So when I look over here, this distance is 1 inch plus 1/8 of an inch. So if I were to write it, I would write 1 by 8 of an inch. So did you understand how the mechanical drafting scale works? So I could use the same thing to do measurements onto this side. What if I were to measure this distance? It would be, this whole thing is 1 inch, so from 0 to right in the middle is how much? Is half an inch, right? So if I were to write it, that would be how much? 1 by 2 inches. Okay, for 1 by 2 inches for this distance. Got it? So this is how our mechanical drafting scale works. Now again, why? Because we are working usually with small little machine parts, and so that's why you would use this scale to do more detailed works on a bigger scale. Okay, let's jump to the last scale that we have over here. That is the metric scale. Now the metric scale is used, as I said, all over the world. It's really simple to use. It's used a lot like what you have over here as the civil engineering scale. Now it's measured in different scales like 1:100, 1:200, 1:300, 1:50, 1:10, 1:20. Just like all different architecture scales. But what that stands for is, let's find some place over here. So I'm going to erase some of my stuff. So let's go ahead, or let's go to the next page. Okay, so I'm on to my next page. I'm going to zoom out and copy my scale down here. Okay, I have my scale. I'm going to put it right here just to make it easy for us to use that for dimensioning. Now again, if I draw another plan, or I'm drawing, maybe I will just draw maybe an elevation of a building, right? So these would be some windows, okay, and this would be maybe some weird opening. I would have another door here. This would be a canopy, all that stuff. Then I probably might have a tree here. Okay, so you get the idea, right? So now if I were to measure this building, or even draw this building on a metric scale, I have to understand what 1:100 stands for. Now what this stands for is 1 centimeter on your drawing corresponds to 100 centimeters on site. Okay, so 1 centimeter is equal to 100 centimeters is how much? Is 1 meter. Okay, so that's our 1:100 scale. So if I have to measure this distance or draw this, I would take my scale, put it right there, and try to measure it. It's really easy. So I'm going to zoom in so we can see it more clearly. Okay, so it starts with 0, just like the others. So you can get those extra, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.1, 9.2, 9.3, right? So how much is that? See, you see 1 meter right here. So that distance is 9.3 meters, or 930 centimeters, or usually they write it as 9300 millimeters. You see how easy that was? So if I were to measure something else, now let's see, I want to measure the window, which is right here. How much is that? From 0 to is a little less than 1.5 meters, right? So it's 1, 1.1, 1.2, 1.3, maybe 1.4 meters. So the distance that we have is how much? 1.4 meter, or 140 centimeter, but usually it's always written in millimeter, so that is 1400 millimeter. Okay, so now you use this same scale, which you see over here, for pretty much an engineering drawing, an architecture drawing, mechanical drawing, civil drawing. So for all that, you're just using one scale. So sometimes you feel, hey, why am I using 10 different scales for working in the US, and why not we just use metric? Now again, because these are the standards set by ANSI. So what is ANSI? ANSI. So this is the national standard. So it's American National Standard Institute. Now these standards, ANSI standards, are used by architects, so it's really important to know what ANSI stands for. Now there are some more standards that we use. One is ASEE, standing for American Society for Engineering Education. Okay, so American Society for Engineering Education. This is ANSI, standing for American National Standard Institute. Now there are some more, which is SAE, that is the Society of Automotive Engineers. Society of Automotive, making cars and stuff like that, right? Engineers. And I would say the last one is for mechanical engineers, this ASME. And as you can see, it's American Society of mechanical engineers. So these are pretty much all the standards that we use over here in the US: ANSI, ASCII, SAE, and ASME. Alright, so we are pretty much done with our scales. I know it was a really long chapter, it takes time, but it's really important to understand how scales work. Now, in part 3 of my class today, I'll be showing you how to do some more sketches with drawing lines, circles, and ellipses. And we go to some more theory that you see over here, but that really wouldn't take much time. So I probably might have maybe another 35-40 minutes of class left for chapter 1. Alright? Okay, I'll see you soon.